Hi, we are the participants of TI India Analog Design Contest 2012. We are team number 67-1 and we are from Sona College of Technology.
This is the low pass filter circuit where we have used two op-amps to find out the phase relation and the phase response and the magnitude response of this low pass filter. To find the voltage magnitude response, we will be using a voltage marker which will be placed in the output. As we simulate this, we will be getting the magnitude response. The magnitude response will have a cutoff frequency of approximately 150 kilohertz. As you can see, this is the procedure to find out cutoff frequency. It's approximately equal to 150 kilohertz. Now to find the phase response, we'll be using phase voltage marker. And place it in the output. And after simulating it, we can observe this is the phase response.
Problem statement given to us, which is to construct a second order low pass filter using using the kit which is provided by Texas Instrument. The hardware implementation is over here. Here we have given a dual input power supply from this function generator to the starter kit, and we have given the output. In the CRO we have got two waveforms. One is the direct input from the function generator. The second one is the output which we are getting it from the starter kit. And the main challenge which we faced during the whole implementation process was to calculate the phase shift between the two signals. In the hardware implementation, we chose spare 2 and spare 3. We didn't go for spare 1. The reason is we had to go for extra connections since we had to get a unity gain from spare 1. And that is the reason we chose spare 2 and spare 3. As you can see from the CRO, you will be having a constant amplitude over a certain range of frequency. As we reach 100 kilohertz, there will be a fall in the amplitude. The level of amplitude gets reduced. So it goes on decreasing. This is the output which we got from the CRO. As we can see, first we are getting a constant amplitude, then it increases, then it goes on decreasing, and then after 1 megahertz, we analyzed and we found out that after 1 megahertz, the amplitude doesn't vary, it remains constant, but the phase shift keeps on varying. This is what we analyzed, what happens if we give an input of more than 1 megahertz. And this is now, it is from the readings which we have obtained, we have plotted the magnitude gain response. And it shows that we have got a unity gain for a certain range of frequency. And after that, after 100k, it starts decreasing. To calculate the phase shift, what we did is we just calculated the displacement between two. We calculated the phase shift using this formula, which is the displacement between two signals into 2 pi by maximum number of divisions. We can see from the phase shift phase plot that there is no phase shift between the two signals for a certain range of frequency. After 50 kilohertz, the phase shift between the two, there occurs some phase shift between the two signals, which is plotted here in this graph. In phase 1A, we got another question, which is to study the transient response on an oscilloscope. We couldn't study this transient response on a normal oscilloscope, so we went for MSO, which is mixed signal oscilloscope. Here you can see study the transient response of a square wave. This is the output and this is the input. As you increase the time period, you can observe the transient response here. This denotes the rise time. Here you can observe the fall time of the transient response. You can observe that as we increase it, we can clearly see the fall time of the transient response.